Okay, so let's solve these composite functions. So they're giving us that f of x equals x squared minus 3x plus 5, g of x equals 3x plus 4, and they're asking us to solve for f of g of x, g of f of x, and f of g of negative 4. So, first thing is that we need to realize that when it's written in this notation, this is another way of saying it, each of these, and these are just it's just an easier form to work with. Okay, so let's start with the first one. What does it mean when we do f of g of x? Well, this just means we're going to replace g of x with what it is, which is 3x plus 4. So this becomes f of 3x plus 4, which means what? Well, it means we're going to take f of x, which is x squared minus 3x plus 5, and we're going to, for every time we see an x, we're going to insert 3x plus 4. So I'm going to insert a 3x plus 4 here and here. Okay, so I'm running out of space here, so let me rewrite it. It's going to be f of x equals what? X squared minus 3x plus 5, x squared minus 3x plus 5. Let me double check that. X squared minus 3x plus 5. Cool. And then we're given f. We have f of 3x plus 4. So we have f of 3x plus 4. So again, what I'm going to do is everywhere I see an x, I'm going to replace it with 3x plus 4. So I have an x here and an x here. Those are going to get replaced with 3x plus 4. And everything else stays the same. So again, what did I do? Just to be, again, super clear here, this x is now 3x plus 4. So this x now is 3x plus 4. This x is now 3x plus 4. So this x is now 3x plus 4. Okay, from here, we just clean it up. So how do we deal with 3x plus 4 squared? That means the same thing as 3x plus 4 times 3x plus 4. So you FOIL, and so if we FOIL, we get, multiply that out, let me change colors here. We end up getting 9x squared plus 12x plus 12x plus 16. We can consolidate these terms, and that gives me, I'm going to write it out here, 9x squared plus 24x plus 16. Okay. Then with this negative 3, and note it is negative 3. I'm going to distribute it into both of these, so that ends up giving me negative 9x minus 12, and then we'll tack on the 5. So this 5 will just come down here, plus 5. Okay. So again, what did I do? I FOILed out 3x plus 4. That is this value right here. I distributed negative 3. That is this value right here. And I brought down the 5. That is this value right here. Okay. So from here, we're just going to take each of these and try to consolidate like terms. So I have a 24x and I have a minus 9, which will give me 15. So I have 9x squared, because x squared has no other term but 9x squared. 24 minus 9 again is 15x. 16 minus 12 is 4. 4 plus 5 is 9. 16 minus 12 is 4. 4 plus 5 is 9. And that is my answer for the first part. So that's 9x squared plus 15x plus 9. So all of this is equal to 9x squared plus 15x plus 9. Okay? And we do the same thing for everything else. So again, for the next one, f of x here is this value, so we're going to be left with g of x squared minus 3x plus 5. Now here what we're going to do is we're going to take, every time I see an x, which is in one place, I'm going to replace it with 9x squared minus 3x plus 5. Okay? Again, I don't have space here, so let me do it on another page. So again, g of x, and I've already forgotten, g of x is what? G of x is 3x plus 4. And we are solving for g of x squared minus 3x plus 5. X squared minus 3x plus 5. Okay, again, all I'm doing is, because we figured out f of x is x squared minus 3x plus 5, we're solving for g of x squared minus 3x plus 5. So that is just a fancy way of saying that every time I see an x, I'm going to replace it with x squared minus 3x plus 5. So let's do that. So we're going to be left with 3 x squared minus 3x plus 5 plus 4, and distribute. So now I'm just going to clean it up. Now it's just an algebra problem. 3x squared minus 9x plus 15 plus 4. And all I got to do to finish it off is combine like terms. Some of the constants that we have to put together. So this is 3x squared minus 9x plus 19. And that's my answer for the second part. What do I say? 3x squared minus 9x plus 19. 3x squared plus 9x minus 19. Yeah, plus 19, sorry. Okay, so the last one is asking us to solve for f of g of negative 4, and there's two ways of doing this. One way is because I've solved for g of negative 4, f of g of x up here, it's this equation here, I can simply just take negative 4 and plug it in here and solve. So let me do that real fast. So negative 4 squared is 16. So this is 9 times 16. 15 times negative 4, just think of a clock. You have a clock is 60. If you go around once, it's 60 minutes, but if you divide it into 4, each one's 15-minute increments, plus 9. So 9 times 16 is what? That's going to give me 144 minus 60 plus 9, which is going to give me what? Well, 144 minus 60 is going to be what? That's 14, that's 84 plus 9, which is 93. And there's my answer. Okay, so one approach is, if you've solved for f of g of x, this is what f of g of x is equal to. So if I replace x with negative 4, then all I did was I replaced x with negative 4, and you just solve. Okay. An alternative approach, let me rewrite this, so there's some space here. Okay. So again, we have f of x, gotta remember to rewrite everything. F of x is x squared minus 3x plus 5. X squared minus 3x plus 5. And g of x is, sorry about this, 3x plus 4. So if I'm solving for f of g of negative 4, this is still f of g of negative 4. And the goal here is that you can just take this g of negative 4 and you can solve that, which gives me negative 12 plus 4, which is negative 8, and now I'm down to f of negative 8. Well, how do we solve for f of negative 8? You take negative 8 and you plug it in here. So f of negative 8, negative 8 squared minus 3 times negative 8 plus 5. So this would be 64 plus 24 plus 5. So what does that give me? That gives me, let me take all of this and rewrite it over here. Well, 64 and 24 gives me what? 88 plus 5, which is 93. And so, well, it's the same value here, right? And so you can work it either way. I like this second way a little bit more because, one, if I made a mistake in the first way, if I made some mistake here with this, which I didn't because we got the same answer, but had I made a mistake there, then I would have missed the problem, right? And the other reason why I like this is you actually have a lesser propensity towards making mistakes because the equations are simpler. They tend to be simpler. So it's just I think it decreases the probability of mistakes because you're dealing with smaller equations, and that tends to make you make less mistakes. So hopefully that makes sense, and I'll see you in the next video.